Okay, this is section 1.3 for Workplace Math 11. So just to have a little reiteration of things that have been covered so far, when we are talking about slope, it is the change in vertical distance over the change in horizontal distance. That is what that little triangle means. Remember, change in. Okay, good thing to have in your head. This can be translated into delta, which is what that actually is. So that is delta. Okay. Delta y over delta x when dealing with slope of a graph. As a result, this can be calculated as I am sorry for that typo. This can be calculated by finding the difference in y values and dividing by the difference between x values. So aka what that means is taking your slope, taking your y value from your point farthest down the line, minusing it from your y value closest. Then you do it again with your x's. Okay? But one good thing to keep in mind, so that you don't have to calculate points every single time you want to figure out if a graph just has a positive, negative, or neutral slope, is to remember our lovely friend, Mr. Slope Guy. Okay? If you've never been introduced to Mr. Slope Guy, I'm going to introduce you to him right now. He's a cool dude, so he can be done in Galaxy Pen. So he is a roundhead. That's okay. And he's a little neutral in expression. Which, I mean, can you blame him? He's a math thing. It's gonna be a little neutral. Okay. Then he is positive and negative. Okay, so this is Mr. Slope Guy. So we have positive slope. We have neutral slope. And we have negative slope. But notice that we don't have any lines going like this. Up-down lines are actually, they don't have a slope. They're actually known as undefined. Because if you have a straight vertical line, your y values don't change, which means when you do a number minus itself, you get 0. And you can't actually divide by 0. It's impossible. You can't have a whole bunch of things and put them in 0 groups. No matter what, they're at least in 1. So, it doesn't work. So if you have a straight up-down line, it is undefined. Okay, so we are going to do 3 examples of calculating slope so you have it nice and firm in your head, and then you're going to do some questions on your own, just like the other sections. So in order to calculate the slope on graphs where you aren't necessarily given the points, if we look along our line, we want to pick points where it's easy to identify what they are. So looking at this graph, I'm going to see, okay, so there's probably a pretty good point here. Remember, points are listed x, comma, y. So this is 4, 3. Then we don't really have another good point except for down at 0, 0. So remember, our slope is change in y over change in x, or y2 minus y1 over x2 minus x1. And the point, just how to know which one's 1, which one's 2, whichever one is farther down the x-axis. So if we're looking at our points, we have 0, 0, and 4, 3. So that means that this would be 0.2. This would be 0.1. So we would put in 3 minus 0 and 4 minus 0, which is pretty straightforward, and we end up with 3 over 4 as our slope. Okay, so make sure it lines up with our Mr. Slope Guy as positive, positive, positive fraction. We're good to go. Next, we have our points given here, so we're just going to use those ones that are given. And we have, what do we have? We have 9, 5. And we have 0, 10. Okay, so y2 minus y1 over x2 minus x1. So we have 5 minus 10, 9 minus 0. We're going to end up with negative 5 over 9. Okay, slope fits with negative for Mr. Slope Guy. Let's double check. Yes, negative slope. It is the correct directionality for it. Negative fraction, we're good to go. There we go. That's our final answer for that one. Next, we have another point where our points are given, so we're just going to use those ones. We have 6, 10, and 3, 5, because remember it is x, y when you are listing points. So y2 minus y1, x2 minus x1, 10 minus 5 over 6 minus 3. So we get a slope of 5 over 3. Now, one way you can also double check if your answer is correct is put your slope in. So this is a slope of going up 5, so 1, 2, 3, 4, 5, and over 3, 1, 2, 3. Are we at the other point? Yes, so our slope works. Okay, there's different ways to figure it out. Some with calculation, some not. Okay, so we have, what numbers do we do here? 1, 2, and 3. So figure them out. Try your best. Read the questions very carefully. Okay, and then pause the video, figure it out, unpause when you're done. See you when you're done. Okay, question 1 is asking you to identify which line is steeper after you calculate the slopes. So I'm going to calculate the slope for line 1 is 3 over 5. Line 2 is 1, 2, 3, 4, 5, 6. 6 over 4. Which one is steeper? That should be a pretty easy answer. If you put them down into decimals, which one's going to give you a number greater than 1? Line 2. Line 2 is steeper. Okay. For question number 2, very, very easy answers. Because line 1 is 0. Line 2 is undefined. Because you cannot divide by 0. Okay. Then we are on to question 3. Question 3 says, on a graph, draw this and this. So, but with our graph, we are given a point at 1, 4. So that point is given. You need to draw 2 lines. You need to draw a solid line that passes through point A and has a slope of 6 over 5. What that means is you go up 6 over 5. So you should end up all the way over here. And it is a solid line. Make sure you use a ruler for this. I don't have one with me at home, so I'm not using one. You need to make sure you use one for yours. Next, we have a dotted line that passes through point A and has a slope of negative 3 over 2. So if this one's positive, negative needs to be going in the opposite direction. So we go down 3 over 2. So down 3 over 2, we can draw another point and put our dashed line in. Make sure you use a ruler for this. All right, easy, easy. Now, why are we doing all of this work with slope? We've already used it with percent grade, with elevation and all that stuff. But that's not the only thing it's used for. Slope can also be used to show rate of change, how fast something is changing. So to show rate of change. But what is rate of change? Rate of change is the rate at which one variable changes compared to another. So one thing that you need to remember is when you are looking at each scenario in a graphed situation, you have 2 different types of variables. You have an independent independent variable and a dependent variable. Which variable do you think is the one that can be freely chosen, is not dependent on any other value? If you thought independent, you're correct. Okay, so your independent variable is a variable whose values can be freely chosen no matter what. And another thing to keep in mind is this is always on the horizontal axis. Okay, so x-axis, horizontal axis. Okay, then the other type of variable, if you seem to remember, is your dependent variable. And this is a variable whose values rely on the value of another variable. So if you're going 10 miles an hour, time's going to keep going regardless of whether you're moving. But how far you've gone depends on how long you travel for. So if you're looking at time versus distance, that's why whenever you see a time versus distance graph, time is always going to be on the bottom and distance is always going to be your vertical axis. So to keep in mind, this is your vertical axis. Okay. Next, we have an example to show how to do these kind of questions. So Willard works as an electrician and earns $12.25 per hour. What is the dependent variable? Well, how much he makes. Time keeps going regardless. How much he makes is dependent on how much he works. So our dependent variable is time or hours worked. Okay? Between hours worked and income. Hours. Okay, you don't get paid if you don't work. Now we need to graph the scenario. One thing I like to do when I'm graphing a scenario is make a table to make it easier. So if he works nothing, he gets nothing. If he works 1, he gets 12.25. If he works 2, he gets 24.5. If he works 3, he gets 36.75. Okay? But now that I have a couple points, I can put those on and just connect them with a line. So 0, 0, 1, 12.25, 24.5, 36.75. And what I could do if I had a ruler with me is draw a straight line. That's actually not too bad. Okay, so we can kind of see, okay, so now if he works 4 hours, how much is he going to make? Oh, he's going to make just shy of 50. If he works 5 hours, he's going to make $60. Okay, so we can use our graph now to show what he makes. So what is the slope of the graph? The slope of the graph is 12.25 per hour. Like, it's pretty straightforward. 12.25 over 1. And go up 12.25 for every hour he works. Okay, and what does it represent? It represents that he makes an hour. Okay, so if you look at 5 hours, how much is he going to make? Look at your 5, go all the way up, get your point, go all the way over. He's going to make $60. Now, what if he makes $183.75? But our graph doesn't go that high. Guess what? Backwards math. We know 12.25 times the number of hours worked gets you how much you make. Okay, so if we make 183.75, we can work backwards since we have multiplication here. How do you cancel out multiplication? You divide. So those are going to cancel each other out. But what you do to one, you gotta do to the other. So divide it out, see what you get. And you get, let's see, how many hours? 183.75 divided by 12.25. 15 hours. Done. Okay. You have some questions to try on your own. Ooh, that's a lot of questions to do on your own. Do your best. Try a couple. Unpause the video. See how you did. Try a couple more. Unpause the video. See how you did. Don't try to do them all at once, because it'll be confusing. Hi. Now that you've at least gotten 4 done, we're going to go over 4. So, his average rate of kilometers per hour. Remember, there are 60 minutes in an hour. 30 is half of 60, so we need to double the amount of kilometers. His rate is 6 kilometers per hour. What is the independent variable? Remember, time is independent. It keeps going regardless of what you are doing. If he does not change his pace, how long will it take him to walk 36 kilometers? If he's going 6 kilometers an hour and he wants to go 36 kilometers, it's going to take him 6 hours because 36 divided by 6 is 6. Okay, moving on to question number 5. Janine's car needs repairing and she borrows $600 from her brother to pay the bill. She repays her brother $40 a week. Write an equation to show the relationship between how much she owes her brother and how much she pays each week. Okay, so if we have that, we want one variable on either side of the equation. So we are going to do O because we want to know how much they owe. And we go, okay, so how much did she start with owing? She started with owing $600. And when you're paying money back, are you making your number bigger or smaller? You're making it smaller. So minus 40, W for weeks. That's it. Okay. Graph the information. What is the slope? Okay. Look at it. We need 60, 40. Not so nice numbers. So we can count how many squares we have. I believe it was 15. We will see. 1, 2, 3, 4, 5, 6, 7, 13, 14, 15. I was right. Okay. But we have 15. We need to go all the way as high as 600 and 40. So, or sorry, number of weeks and amount owed, I should say. So this is weeks because remember, time keeps going no matter what you do. And amount owed. Okay, and that needs to start all the way up at 600. So I'm going to do every one is 50. So this would be 100, 200, 300, 400, 500, 600, 700. It's okay that it goes a little higher than the number we need. We don't need that much, so it's okay. Now, each one now is going to be, let's see, if we do each one is a week. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, pretty straightforward. We start at 600. Do week 1, minus 40, we get 560. And we just keep going down the line. Okay, a good way to do it, make sure you make your table because these aren't starting to not make all that much sense. So, at the end of week number 6, so minus 40 times 6, we should be at 360. Whew, I am way off. That's not good. We're making a table. But we're not going to do every single week because that's just going to be way too many points. So we know at 6, we should be at 360. 360. Okay, what about 10? We should be at 200. That's an easy number. And what about 14? 14, we're at 40. That means 15, we're at 0. Okay, so connect them with a line to the best of your abilities using your ruler. Make sure they're in the right spot. If one doesn't line up, something went wrong. Okay, so that's number 5. We're going to move on to number 6. If you don't have it done, pause the video. Okay, moving on to number 6. Calculate how much commission George will earn if he makes sales of 500, 1,000, and 2,000. If he gets 12% commission, how do you find out the percent of a number? You guys should all know this very well. 500 times your decimal version of your percent. So, if he makes 500, he gets 60. If he makes 1,000, he gets 120. If he sells 2,000, he gets 240. Pretty straightforward. Write an equation. Let's see. Sales times 0.12 equals his commission. What is the independent variable? The independent variable is sales. All right, because he doesn't get commission if he doesn't make sales, but other people can make sales. It's not related. It's not reliant, sorry. Okay, next we need to graph it. That's a little more tricky for you guys, but that's okay. So what this is going to mean is if he sells nothing, he makes nothing. Okay, so 0 and 0. Pretty straightforward. Okay, remember sales is independent of commission, so sales, commission. How much does he sell? Well, every 5 will be 100. Every 5 will be 500. Sorry, that won't fit though. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 15. We have a scale of 2,000. Doesn't fit all that well. What can we do? Well, we know our sales commission goes as high as 240. That one we can do. 20, 40, 60, 81, 20, 40, 60, 82, 20, 40, 60, 83. So that gets high enough. So that's pretty straightforward and easy. But we need different values on the bottom. So I'm going to do each one equals 250. So that means this would be 500, 1,000, 1,500, 2,000. It's not the best number, but it'll work for our graph. Right? So if he sells nothing, he makes nothing. If he sells 500, he makes $60. If he sells 1,000, he makes $120. If he sells 2,000, he makes $240. Those are pretty straight and nice and easy to join together. That's it. Okay, so now if George earned a commission of $210, how much did he sell? That's working backwards, just like we did in the example question where we were told how much they made. So 210 divided by 0.12. He sold $17.50. Okay. So that's it for 6. We can move on to 7 if you have it done. If you don't, pause the video, keep working, get it done, and come back, because now we're dealing with word problems. Okay, now that you have it done, Maria is filling a rectangular swimming pool with water. She knows that the pool will hold 13,500 gallons of water. After 45 minutes, she estimates that there are approximately 225 gallons of water in the pool. What is the rate of the pool being filled? We need gallons per minute. So 2250 divided by 45. Gets us 50 gallons per minute. Looking at B, how long will it take to fill the pool? If we need 50 gallons per minute, we need to fill 13,500 gallons. 13,500 divided by 50. We get it will take 270 minutes, which is 4.5 hours. Okay. Tom is on a long haul truck drive. Is a long haul truck driver on the first leg of his trip. He traveled 380 kilometers in 5 hours. If he drove a constant speed, what was his rate of travel? 380. We want kilometers per hour, so divided by the number of hours, and we get 76 kilometers per hour. After the 5th hour, he sped up. He decided he wasn't going fast enough. After 9 hours, he had traveled a total of 764 kilometers. What was his average rate of travel after he sped up? We need to find what the difference is between the amount that he traveled, though, because we all can do the subtraction of 9 minus 5 getting us 4 hours, but we need to find how far he went in that 4 hours. So 764 divided by 380 gets us 384 over 4, and he sped up to a whopping 96 kilometers per hour. Okay, that is 8. If you don't have 9 done, pause the video, get it done, come back. Okay, 9 is Miriam is reading a book at a rate of 0.6 pages per minute. How long will it take her to read an entire 321-page book? 3, 2, 1. That's a funky number to be in here. Times 0.6. It will take her I think I did that wrong. Give me a minute. I think I'm getting a little confused. Sorry, I did get a little confused. So if we have 0.6 pages per minute, how did I know I was getting the wrong answer? I knew I was getting a wrong answer because 321 was larger than the answer I was getting. And when we are doing less than a page a minute, don't you think it should take more minutes than there are pages? Number sense comes in handy. So 321 divided by 0.6 gets us 535 minutes. That's a long time to read a book. After 2 hours, how many pages will she have read? 2 hours is how many minutes? If 1 hour is 60, 2 hours is 120. So 0.6 pages per minute times 120 minutes. We get she will have read 72 pages. Hopefully that is all nice, good, and clear in your head. You are going to try pages 50 to 54 in your workbook. Remember, if you have not bought it, you cannot write in it. You are doing numbers 1 to 7. Good luck.